We're given the problem, what is sine of theta if cosine of theta equals 4/5 and theta is in quadrant 2? We're going to use the Pythagorean identity to solve this problem. And again, remember, we are doing right triangle trig here. On the unit circle, all of these angle measures are comprised of special right triangles. So if you look at this Pythagorean identity, it's the same as the Pythagorean theorem, a squared plus b squared equals c squared, where your sine of theta and your cosine of theta are the legs of that special right triangle, and your hypotenuse is the radius on the unit circle, and if it's a unit circle, the radius is always 1. 1 squared is 1. So let's go ahead and get started. I'm looking for sine of theta, so I'm just going to plug in what I know into the Pythagorean identity. I don't know sine of theta, so I'm going to keep sine squared theta plus cosine is 4/5. I need to square it, and that equals 1. So now let's just clean this up. I have sine squared theta plus power property. You need to square the numerator and the denominator. 4 squared is 16. 5 squared is 25 equals 1. I'm still working at getting sine squared theta by itself because I need to solve for sine of theta. So I need to subtract 16/25 from both sides. Well, I'm subtracting a fraction, so I know I'm going to need a common denominator, but these are super simple. So if I need a common denominator of 1, or excuse me, of 25, I'm going to rewrite 1 as 25/25 minus 16/25. And then I am now left with sine squared theta equals 25 minus 16 is 9. So we have 9/25. And I want to get rid of that square. And we undo a square with a square root. So I'm going to square root both sides. I am going to do plus minus here. And now don't forget, this goes back to topic 5. I can break this up as this is the square root of 9 over the square root of 25. So this one works out. It's nice and clean. I'm going to get sine of theta equals the square root of 9 is 3. Oops, I forgot my plus minus. 3. Square root of 25 is 5. But now remember, we were asked to find sine of theta if theta is in quadrant 2. So if I'm in quadrant 2, here's quadrant 2. And remember, sine relates to y values. So if I am up here in quadrant 2, sine is going to be positive. So therefore, I'm going to say sine of theta equals positive 3/5. Now, if my problem said theta is in quadrant 3, sine is negative in quadrant 3, so therefore my answer would have been negative 3/5. So it depends, whether it's positive or negative depends on what quadrant it's in. And let's take a look at negative angles in standard position. Actually, let me flip the page. Let's do this on a separate sheet. So negative angles in standard position. So I'm just going to go ahead. I'm going to draw X and Y axes. Here's my X axis. Y-axis. And recall that whenever we're drawing an angle in standard position, you always start on the positive x-axis. That's my initial side. Now, if I've got a negative angle, I move clockwise. Positive angles move counterclockwise. Negative angles move clockwise. So that means if I'm going to let's do this one in degrees. I'm starting over here at 0 degrees. and then you'd go clockwise, which would then put us here at negative 90 degrees. And then if I would move again, another negative 90 degrees, I'd be at negative 180 degrees, negative 270 degrees, and then a full rotation, I'd be at negative 360 degrees. So now let's say I want to find, let's do theta equals negative 150 degrees. So I am starting here on the positive x-axis. This is my initial side, and I'm moving clockwise. Well, if I'm moving clockwise and if I come up to negative 180, I've gone too far. I need to kick it back 30 degrees. So that means I'd be right in here. And then I'm also going to use this notation. This is the direction of my movement. I am moving clockwise. So here, theta equals negative 150 degrees. Let's go ahead and do one in radians. And I'm just going to draw my x and y axis. And my initial side of my angle. And so now in radians, here I'm at 0 rads. Here I am at negative pi over 2 radians. Coming up over here, I'd be at negative pi radians. And up here, I'm at negative 3 pi over 2 radians. And then again, forgot to draw my arrows, we're moving this way. And then that full rotation, I'm at negative 2 pi radians. So if I say, let's find negative 2 pi over 3. So theta equals negative 2 pi over 3. So if I'm over here and I'm moving, and now notice I got a fraction. I've got a 3 in the denominator. Super simple, just to kind of bounce them off of the x-axis. I can rewrite both of these easily with a 3 in the denominator. So negative pi, if we want to write that with a 3 in the denominator, this would be negative 3 pi over 3, equivalent to negative pi. So that means if I'm starting here and I'm moving this way, if I hit the negative x-axis, I'm at negative 3 pi over 3. Well, I need to be at negative 2, which means I've gone negative pi over 3 too many. So that means I'd be right here. And again, I'm going to draw that notation that we are moving in a clockwise direction. And so here is the angle negative 2 pi over 3.